Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. This is a question I suppose that I had alluded to earlier when I said that there were some questions on here that required a lot of interpretation. This is, I think, the most challenging question on the test. Let's have a look. The strength of earthquakes is measured on the Richter magnitude scale with values typically between 0 and 8, where 8 is the most severe. The Gutenberg-Richter equation gives the average number of earthquakes per year n. So average number of earthquakes per year is n, which have a magnitude of at least m. So the magnitude, this is the strength, and it's measured in m. And then the number of earthquakes per year is given by n. Okay, for a particular region, the equation is log base 10n equals a minus m for some a, and we say a is a real number. Essentially, a real number is anything that you could put on the number line. So it could be like root 2 or root 5, it could be pi, it could be infinity, actually anything up to infinity, any value you want essentially. This region has an average of 100 earthquakes per year with a magnitude of at least 3. Find the value of A. So this is a logarithmic equation right here. It looks a little challenging, a little intimidating, but at the end of the day it's an input-output question. We have n, which we don't know, a, and m, 3 things we don't know, but they give us 2 out of the 3 unknowns. So if we have 2 out of 3 unknowns, input those values and essentially n solve. Looks intimidating, but it's an input-output question. So a region has 100 earthquakes per year. 100 earthquakes per year is given by n. So we know n is equal to 100. And with a magnitude of at least 3, so which have a magnitude of at least m. So in this case, we know that m is equal to 3. So for finding the value of a, I'll just put part a here. This is our equation. Log base 10 of n is equal to a minus m. What do we know? We have log base 10 of n is equal to 100, a minus, and m is equal to 3. After that, input output, let's n solve for a. Okay, so let's go to the calculator screen and work that out. Menu, algebra, numerical solve. In this case, we're going to want to find our log function right here. Log base 10 of 100. So it kind of scaffolded us in terms of what values to put in. Then we have a minus 3, and then we want to solve for a. Okay, and the value is 5. So let's go back to the document and write this out. A is equal to 5. Okay. Question B. The equation for this region can also be written as n is equal to b over 10m. Find the value of b. Okay. So this is actually going to be important for later. This question kind of reads almost like a paper 2 in that you need to draw from earlier parts. So find the value of b. So this is still for this given region, this unidentified region, but we're still within that region. And we know that n is equal to 100 and m is equal to 3. So once again, n, m, and b, 3 things, 3 variables we don't know, but we do know n and m. We know 2 out of the 3. So again, we can actually n solve in this case. So let's write that equation out. N is equal to b over 10m, and n we said was equal to 100, b we don't know, and m was equal to 3. And in this case, once again, we can n solve for b. So let's go back to the calculator and work this out. Menu, algebra, numerical solve. 100 equals, set up a fraction, b over 10 power of 3, and then we ask calculator to solve for b. Alright, so it looks like 100,000. So b is equal to 100,000. Alright. Not too bad so far. Not too bad so far. Part C. Given that m is greater than 0 but less than 8, find the range of n. Okay. So given that m is greater than 0 and less than 8, find the range of m. Alright, so this one requires a fair bit of interpretation, I think, and some context to try to see what is going on. So m is the magnitude of an earthquake, and n is the number of earthquakes. So what do we have here? Given that the magnitude itself is greater than 0 and less than 8, find the range of n, the number of earthquakes per year. And this is where I said it kind of reads somewhat like a paper 2. In terms of finding n, we would have to go back to this equation right here. So n, remember, is the number of earthquakes. The number of earthquakes, we found out what b was. B, we said, was 100,000. And m is, in this case, the magnitude, which have a magnitude of at least n. M is the magnitude or strength of the earthquakes. So given that we have a strength that is greater than 0 but less than 8, find the range of n, the number of possible earthquakes. So how would we find n? Well, it's given by this equation right here. So let's go ahead and write that out. N is equal to, we found out what b was, over 10m. And so I suppose one thing that might kind of scaffold or cue this question is, this is a rather peculiar question in itself, this one right here, finding the value of b, because they already asked us to do something with this skill, this input-output question, for part A, that they would ask us to essentially solve another input-output question in this context, unless they wanted us to do something with it, potentially. So maybe that would be potentially a question to ask. How could we use this question? Are we going to need to make use of this value of A or B or so on? Okay. So number of earthquakes is given by 100,000 over 10 to the power of their magnitude. And in this case, we're looking for earthquakes which have a magnitude greater than 0 and less than m. So let's find the total range for n. So if m is, let's say, equal to 0, let's find the range of n. So m is greater than 0. We have 100,000 over 10 to the 0. You can put this in your calculator. Anything to the 0 actually is just 1. So we have 100,000 over 1. In this case, 100,000 earthquakes, which I suppose kind of makes sense in some sense. Like if they're infinitely small, we would expect potentially a lot of earthquakes. And so this would be the upper bound. So this would be the upper bound. This is like the highest number, the upper bound. And let's go ahead, and we also have, n is equal to 100,000, that was the value of b, over 10 to the m, but in this case we also have 10 to the upper end of 8. And so what could this be? So once again, what we're doing here, we have this equation which gives us the number of earthquakes. Number of earthquakes is equal to 100,000 divided by 10 to the power of the strength of the earthquakes. So if we have strength of the earthquakes between 0 and 8, what are the total range of number of earthquakes that we could possibly have? So if we put in the lower bound of 0, that is to say super weak kind of earthquakes, we could have up to, let's say, 100,000 in this certain region. And if we put in a value of m for a very strong earthquake into this equation of n is equal to 100,000 over 10 to the m, if we put in a very strong earthquake, what are the total range of number of earthquakes that we can have? So 100,000 over 10 to the 8. I'm going to work that out. Actually, no, I'll go to the calculator to work that out. So on the calculator screen, set up a fraction, 100,000, 10 to the 8, and it gives us 1 over 1,000. Let's actually write this out as a decimal, 0.001. So let's go back to the document here, 0.001. Okay, so the total range, the range of n, in this case we want to use inequalities, and we would say that n is greater than 0.001, using the same symbols here. We're not including, so n is greater than 0.001 and less than 100,000. All right. Okay, so kind of a challenging question in terms of interpreting what it's asking. All right, let's go on to question D. Within this region, the most severe earthquake recorded had a magnitude of 7.2. So m was equal to 7.2 in this instance. Find the expected length of, oops, sorry, I think there's something actually right above. The expected length of time in years between earthquakes with a magnitude of at least m is 1 over n. Okay. The expected length of time in years between earthquakes with a magnitude of at least m is equal to 1 over n. Okay. Within this region, the most severe earthquake recorded had a magnitude of 7.2. Find the expected length of time between this earthquake and the next earthquake of at least this magnitude, giving your answer to the nearest degree. So we have this equation, and we're coming back to it. This is a pretty central equation, I suppose, right here. Going down here, looking at this one, same thing, except our b value, which we found, is here. The number of earthquakes is equal to 100,000 divided by 10 to the power of m. This will tell us the number of earthquakes that we could possibly expect of a given magnitude. So writing it out once again, 100,000 over 10 to the m. In this case we have a magnitude of 7.2. So what this formula gives us is it's going to tell us how many 7.2 magnitude earthquakes would we expect within 1 year. So we have 100,000 divided by 10 to the, and then m was equal to 7.2. So super strong earthquake, how many would we expect to have a year? So let's go into the calculator and work that out. I'm going to set up a new screen. Let's get a fraction. 100,000 divided by 10 to the, 10 to the 7.2. In this case, very small number. N is equal to 0.000631. So going back to the document, N is equal to 0.000631. And this is actually 1, 2, 3 sig figs, so that's okay. Alright, so how many of these massive earthquakes would we expect to have a year? Well, the number of earthquakes we would expect to have a year is very fraction of a percent. It occurs very infrequently. So, and the number of earthquakes that we would expect to have of this magnitude every year is, we wouldn't even expect to have one of these earthquakes. The expected length of time in years between earthquakes with a given magnitude is equal to, of at least m, is equal to 1 over n. So we found out what n is equal to, and that means 1 over this value of 0.000631. In this case, if one of these earthquakes, we would expect to have how many earthquakes of this magnitude every year? Not even one. So if we take 1 over this value of 0.00631, that would tell us how long between earthquakes we would expect between, such violent, heavy magnitude earthquakes. So working this out, I'm just going to work it out on the small calculator that I have beside me. We have 1,584.78, or 0.79 rather, or 1,580 years, I guess, to 3 significant figures. Alright, let me just see if this is all correct. 10,000 divided by 0.00. Whoops, sorry, I think I forgot 1 0 here. There shouldn't be so many zeros here. This should only be 0.006. And in that case, this should be 0.00, and that would make this 158 years. Okay. 150. Let's see. 5. Just 158. Let me just change this decimal point real quick. 479. Okay, so 158 years. I just want to type this in just once more. 100,000 divided by 10 to the 7.2. Okay. Good. Alright. So I think that's a pretty challenging question in terms of just interpreting what it's asking and keeping track of n and m in this case. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.